Hello, Hacktivity. Thanks for having me. This is my first Hacktivity and first visit to Budapest. In my talk, I will show you how to hunt for security vulnerabilities in a web application built with Adobe Experience Manager. It's a popular software for making shiny websites used by high-profile companies. Web applications built with Adobe Experience Manager is a long phrase, so I will use AM webapps term instead. Some words about myself. My name is Mikhail. I came from Russia. I do bug hunting on Bugcrowd and HackerOne platforms. On Bugcrowd, I'm in top 20. I do security research and was acknowledged by many well-known companies. Sometimes I present results of my research on different security conferences. Also, I have a full-time job. I worked for Ingram Microcloud as application security engineer. But just before the conference, I decided to join Acronis company as a senior security researcher. So why this talk? As I've mentioned, Adobe Experience Manager is quite popular choice among high-profile companies. Here you can see some well-known companies that have public bug bounty programs or vulnerability disclosure programs, and that use Adobe Experience Manager. I used a service called WhatRuns, and that service gave me a list of about 10,000 domains that have Adobe Experience Manager running on them. For about 6,000 domains, main site was running Adobe Experience Manager on URL HTTPS domain name or HTTPS 3w domain name. You can see here that IAM is quite complex. It has many layers in the architecture, and the attack surface is quite big. There are 26 known CVEs exist. I want to specially outline 3 Apache projects or open source projects that form a core of AAM. They are Apache Felix, Apache Slink, and Apache OAuth-GCR. Apache Felix is used to manage so-called OSGI bundles. All functionality in AAM is packed inside OSGI. Apache Felix gives you REST API to manage content repository, and also gives the ability to expose servlets from OSGI. Apache OAuth-GCR is a content repository. Everything in AAM is stored as properties for some nodes in GCR. And all nodes shape a tree structure starting from GCR root node. This year I discovered new exploitation techniques and security vulnerabilities in AAM. And it's perfect time to share my findings here. I want to give special thanks to Jason Mayer, who helped me with AAM license and also shared some nice thoughts with me. I want to mention some previous work on this topic. In 2015, I found an authenticated remote code execution in AAM web application during I participated in a bug bounty program. Same year, I made a talk on PhD's conference in Moscow that describes techniques I used. In 2016, Peter Atkins from England made a very nice blog post about getting RC on signed out Livecom web application that belongs to Microsoft. Not long ago, a renowned bug hunter from Sweden Franz Rosen on SecT conference gave a talk about his experience with hacking AM web apps. I highly recommend looking into his presentation. And finally, Jonathan Bowman wrote a very nice blog post explaining how he found an XSS on philips.nl site. Just a side note, all mentioned vulnerabilities in my talk were responsibly reported to resource owners or Adobe Product Security Incident Response Team, and I hope they are fixed now. First, I want to show you how AM is commonly deployed in practice. What is AM Dispatcher? Why is Dispatcher so important for security of AM web applications? And the more vital question, how can we bypass AM Dispatcher? In common AM deployment scenario, there are three main components: author instance, publish instance, and the dispatcher. Author instance is placed deep inside backnet. It's not visible from the internet. All content is published on author instance and through replication mechanisms is propagated to publish instances. And the user communicates with publish instance through AM Dispatcher. But there can be additional components that sit between user and AM Dispatcher. For example, web application firewalls or CDNs like Akamai or Cloudflare. AM could be deployed on-premise or in the cloud, like AWS. Physically, AM Dispatcher is a module for web server, Apache or IIS. One of the purposes of AM Dispatcher is providing first security frontier. It filters out unwanted requests that don't fit security policy and prevent them from reaching a publish instance. In theory, as stated in the official Adobe documentation, AM Dispatcher is an extra layer in layered AM security. However, we see in practice that it's only one layer. The truth is that AM admins rely on AM Dispatcher heavily, and no one configures publish instance securely and install updates timely. And that's very good for a bug hunter. Bypassing AM Dispatcher allows to talk to those insecure components on publish instance, and this way pawn the whole web application. In my arsenal, I have four methods to bypass AM Dispatcher. The first one is CVE from 2016. It was disclosed to the public in the blog post made by Peter Atkins. It still works quite well because, as I've said, admins are too lazy to install security updates. And the second one was discovered by me this year, but just before the conference, Adobe reached me and asked not to disclose details because the fix is not ready yet. So I'm sorry for that. But of course I will disclose all technical details later. The next method at multiple slashes works sometimes against weird dispatcher policies. And the final method, server-side request forgery, is a universal weapon for dispatcher bypass. Let's discuss how to bypass the dispatcher with CVE. Here you can see a minimal dispatcher policy that was recommended by Adobe before CVE exists. This policy is too restrictive. Usually you extend it by adding additional rules that allow custom requests. Policy contains rules that are applied sequentially to the request. And what's important to know that the last rule that matches the request is applied. Rule can be of type deny or allow. If none of the rules match the request, the default deny rule is applied and blocks the whole request. Here we can see the remaining rules of the policy. And so here is the bypass. It's stupidly simple, I should say. If we try to access query builder JSON servlet on route bin query builder.json, our request will be blocked by the dispatcher. But if we add /a.css or /a.html to the end of the URL, we can access query builder JSON servlet without problems. And what the hell? Let's try to analyze the logic of the dispatcher. When we are accessing route bin query builder.json, we are blocked by rule 0090. It's the last rule that matches our request, and it blocks all incoming requests where URL ends with .json. When we add /a.css to the end of the URL, last rule that matches our request is 0041 that has allow type. This is how it works. Of course, Adobe fixed this issue and issued new minimal dispatcher policy. Now rule 0041 that should allow access to CSS or JS files is changed. Now the dispatcher looks for the real extension in the URL and not for the last symbols. That makes sense, of course. More rules of the new policy and the last ones. Now, if we are trying to access route bin query builder.json or bin query builder.json CSS, the request is blocked because now dispatcher looks for the real extension. However, I found a way to bypass the fix, but I cannot disclose details now, sorry. In some cases, we can bypass weirdly configured dispatcher by adding multiple slashes. So if access to /etc.json is blocked, we can try 3 slashes etc.json, and sometimes it works magically. And server-side request forgery in some component on publish instance allows to completely bypass the dispatcher, and later I'll show you some examples of SSRF vulnerabilities I discovered this year that are suitable for dispatcher bypass. So to wrap up, IAM dispatcher usually is the only security layer, and there are easy methods to bypass it and access vulnerable components on publish server. Now let's move on and discuss how we can quickly separate smelly IAM web apps from secured ones. On the first step, we can try to access routes presented on the slide. If we get JSON in a response that contains properties or values that have such words as GCR or Slink or CQ, we are facing with IAM web app. For example, several Twitter subdomains are running Adobe Experience Manager. When we access /.json, we see JSON response with properties like GCR created by. When we access /x.json, we see JSON response that contains values like GCR content or CQ page. And that's a clear indication of running IAM web application. Additionally, we can try to access some servlets that are usually left exposed. For example, we can try to access login status servlet or background test servlet. So you can see that when login status servlet is exposed, we observe authenticated equals false string. And when background test servlet is exposed, it runs 10 cycles of testing routine and outputs the results. Everything in AM is stored in the content repository that represents a tree structure. And that's important. And you feel like a dumpster diver when you're trying to find some valuable data out of this huge and messy content repository during pen testing. What gems can you find? Any sorts of secrets like passwords for databases or online services, encryption keys, secret tokens, production configuration, private information of users like emails, telephone numbers, home addresses, etc. And also valid logins for AM users. Why does this happen? Because AM admins rely on AM dispatcher heavily and don't configure access controls for content repository. I've counted 4 built-in AM servlets that are suitable for retrieving content from GCR. They are default get servlet, query builder JSON and feed servlets, and GQL search servlet. The first one is default get servlet. It allows to get GCR node with its properties. For your convenience, it supports various selectors and formats of data. For example, selector tidy allows to get formatted output. Selector infinity allows to get in one request properties of the current GCR node and all its children. Instead of infinity, we can use some numeric value from -1 to infinity. This value determines the depth. -1 is equivalent to infinity. Format res allows to retrieve files that are normally stored inside GCR data property of GCR content node. For example, when we are accessing route /.tidy.3.json, we are getting formatted JSON that contains nodes and their properties starting from the root node with depth 3. Usually I use following approach for grabbing data. On the first step, I get information about direct children of the root node, but in some cases, listing for GCR root is prohibited. If so, I try to guess valid node names. Common names are content, etc, var, and whom. On the second step, I start to traverse GCR and dump node properties. When depth selector is allowed, we can get the whole subtree of GCR in one GET request. That's very convenient. Some common places to look into. Children nodes of etc usually contain various secrets like database connection string with passwords, encryption keys, and so on. Children nodes of apps system config and apps something config usually contain passwords. Children nodes of var may contain private information that belongs to users. And children nodes of whom can contain profiles for AM users with hash passwords. And normally properties like GCR created by, GCR last modified by, CQ last modified by of any node contain login names for AM users. Here is the real case example from bug bounty program. It was possible to pull database connection string and database password without any authentication. This information was stored in child nodes of etc redacted apps config node. I bypassed AM dispatcher by just appending /a.html to the URL. And this submission was rated as critical. The second and third servlets that are suitable for GCR exploration are Query Builder JSON Servlet and Query Builder Feed Servlet. They support various predicates for searching. That's very convenient. Query Builder JSON Servlet returns information about GCR nodes and all its properties. However, Query Builder Feed Servlet returns information only about nodes, no properties. But never mind, we can extract properties using blind binary search. Here you can see how to access Query Builder JSON Servlet and Query Builder Feed Servlet. On this slide, I collected searches that often rescue me and give me quickly security bugs. In private bug bounty program, I searched through GCR using Query Builder Feed Servlet and found AEM production configuration in a zip archive full of passwords. Submission was rated as critical. In another bug bounty program, I was able to get access to users' profiles through Query Builder JSON Servlet and to grab SAML tokens and hashed passwords. Example from Twitter bug bounty. By searching with Query Builder JSON Servlet, I found node that was writable by anonymous user. And additionally, post requests were allowed, so I was able to upload a SVG file with JavaScript and have persistent XSS on Twitter subdomains that bypass Twitter content security policy. With search shown on the slide, you can get login names for AEM users. Having valid logins, you can try to brute force credentials and further extend your access to AEM. Further, I'll show you how to brute passwords in a right way. When access to default get servlet is prohibited, but Query Builder JSON Servlet is not locked, you can use Query Builder JSON Servlet in default get servlet mode using presented search strings. GQL is a simple full-text query language. GQL Search Servlet allows to search through GCR using this language. This servlet returns only nodes without properties, as it was with Query Builder JSON Servlet. However, again, we can retrieve properties using blind binary search. Here you can see how to access GQL Search Servlet. And one example of the search query, that query allows us to retrieve names of child node of HC node. Now let's look how we can access, how we can get access to AEM as some user. For getting valid usernames, we can use default get servlet or Query Builder JSON Servlet. We have already discussed it, how to do it. And additionally, AEM has default users with names admin and author. User admin is the king of AEM. He has full access to everything. And default password is admin. And it's really a mystery for me, but I'm facing with many web applications built with AEM that have default admin credentials. Also, user has GCR write privilege for node content and has default password also. And good news, everyone, AEM supports basic authorization without any brute force protection. That's insane, I think. Login status servlet is a convenient way to brute force credentials. Here you can see that when credentials are on, servlet returns you string authenticated equals false. and it returns string authenticated equals true when credentials are valid. And we can see how to access this servlet. Here is the example from Adobe Vulnerability Disclosure Program. I found a AEM on subdomain of adobe.com with default admin credentials. And I was able to access System Console. From there, I could install backdoor OSGI bundle and gain remote code execution. Another example is a LinkedIn Vulnerability Disclosure Program. I grabbed usernames using default get servlet and then tried to brute force passwords with login status servlet. For my luck, I was able to find several users with easily guessable passwords. And I finally accessed CRXD console as internal LinkedIn user. Now I'll show you some universal ways to get RC in Adobe Experience Manager. Now I know two universal ways to get RC. The first one is by uploading backdoor OSGI bundle. The second one is by uploading backdoor GSP script to apps node. To upload OSGI bundle, you have to be admin and have access to root System Console bundles. I've made backdoor OSGI proof of concept for AEM of version 6.2. For the second way, you should have write access for apps node and the ability to create new content with Slink post servlet. My OSGI backdoor POC works for AEM version 6.2 or in the newer versions. If you need backdoor bundle for older version, you can generate a skeleton project using shown Maven commands. And then backport backdoor servlet class from my project to the newly created skeleton. OSGI bundle has backdoor servlet that executes arbitrary shell commands passed in CMD parameter. Servlet is exposed on route bin backdoor.html. Let's see a quick demo. So we are cloning a repository with OSGI backdoor. It has jar file with OSGI bundle, and we are trying to upload and install it. We see that bundle is installed. And now we can run arbitrary shell commands by navigating to URL. It works. Another way to get RC is to upload a GSP script. You should take following steps. You should create node with name RC node and the property Slink resource type with value RC type. Then you should create node apps RC type and upload html.jsp script to that node. Finally, you navigate to route rc node.html and have the ability to execute arbitrary shell commands. I created a shell script that automates described steps. Let's see the demo. We are running script and pass 3 parameters to it. The first parameter is URL of AEM web application. The second one is username, and the third is user password. It gives us URL. And now if we open this URL, we can execute arbitrary shell commands. Now I'll present you technical details for server-side request forgery vulnerabilities I found this year. The first one is SSRF in reporting services proxy servlet. Adobe assigned CVID for it. It worked for all modern AM versions. Through this SSRF, you can send GET request to arbitrary URL. And what's notable is that SSRF allows you to see the full response. SSRF can be used to leak secrets from internal network services like metadata service in AWS. You can also use this SSRF to bypass AM dispatcher. And you can always exploit SSRF as reflected XSS. And you don't need to worry about XSS filters in browsers. This is how you can access vulnerable reporting services proxy servlet. Let's see some examples. In private bug bounty, IAM was deployed in AWS. I was able to leak IAM role credentials using SSRF in reporting services proxy servlet. Another example, with SSRF, I was able to bypass AM dispatcher and access secrets from child nodes of etc node. Direct access to etc was forbidden, but via SSRF I was able to access publish instance on localhost and port 4503 and exfiltrate secrets from etc. In Adobe VDP, I was not able to leak anything sensitive with SSRF. I just exploited reflected XSS here. It worked perfectly in Chrome bypassing Chrome XSS filter. Another vulnerability reported by me is SSRF in Salesforce secret servlet. Adobe assigned CVID for it. This SSRF allows to make post requests to arbitrary URL and see the full response. It allows to leak information from AWS, from metadata service in AWS, because metadata service doesn't differentiate between GET and POST requests. And of course, we can exploit SSRF as reflected XSS. This is how we can access vulnerable Salesforce secret servlet. And some real examples. I found subdomain on adobe.com with AM deployed in AWS. This AM had vulnerable Salesforce secret servlet, and I was able to leak AM role credentials. This is how you exploit this SSRF as reflected XSS. I also found the SSRF inside Catalyst servlet that allows to send post request blindly to the arbitrary URL. But Adobe decided not to assign CVID for this vulnerability. What's interesting about this SSRF that you can inject arbitrary headers in the request through CRLF injection. And you can even send get or put or delete requests via HTTP smuggling technique. I'll show you later how to escalate this SSRF to remote code execution. Here is how it works. We send get request, parameter data center is vulnerable to SSRF. In parameter username via CRLF injection, we can specify additional HTTP headers. This is how you can access vulnerable site Catalyst servlet. This is another SSRF that is similar to SSRF inside Catalyst servlet. Again, Adobe decided not to assign CVID for it. Here is how it works. We send post request, parameter analytics.server is vulnerable to SSRF. This is how you access vulnerable, also provisioning servlet. And it's possible in some cases to escalate described blind SSRFs to RCE. For AM 6.2 running on Apache JT, I was able to get remote code execution. It works if cumulative fix pack 7 is not installed on AM. CFP 7 was released in mid of 2017. In AM, there is a term topology. Topology is used for replication, and topology connector servlet in default installation is accessible on localhost only. If we can send put request to topology connector, we can join the topology. Of course, via SSRF, we can do that. And when we reach topology connector servlet on publish instance, we join the topology and reverse replication agent is created automatically. And reverse replication agent tries to replicate nodes from our malicious AM server to publish instance. This way we can upload backdoor GSP script to apps node from malicious AM server on publish instance and gain remote code execution. Let's see how it works. First, I'm trying to check that node with name RC node doesn't exist. It doesn't exist. We are observing access log on publish instance. And now we navigate to this long URL in the browser. In access log, we see that put request was made to topology connector. Now we launch our malicious AM instance and waiting for the connection from publish instance. We see the connection. And now we should see that node with name RC node was created by replication service. Now we can navigate to the URL and execute arbitrary shell commands. Yeah, it works. Let's explore briefly some possibilities for XSS vulnerabilities in AM web applications. There are many ways to get XSS. If you have rights to create new nodes, you can create new GCR node and upload a SVG file here to get an XSS, as I've previously demonstrated for Twitter bug bounty. If you have no rights to create new nodes, but have an ability to create new properties for some node, you can create new property with HTML tags inside. There are several XSSs in SVF files reported by Franz Rosen. You can find technical details in his presentation. VCM debug filter was previously vulnerable to XSS, and additionally plenty of built-in servlets of IAM return unescaped HTML from user input in JSON response, and sometimes it can result in XSS. The first two variants gives you persistent XSS, the rest reflected XSS. But we will look more precisely at the last XSS variant. I found suggestion handler servlet. It reflects pre-input parameter in JSON response without escaping. It's not a vulnerability on its own. However, often AM is configured in such way that content type of the response is determined by a file extension in the URL. So by adding /add a.html to the URL, we can get reflected XSS. So it was reflected XSS submission for private bug bounty program. Denial of service attacks are very funny for AM web applications. because in practice it's very easy to cause DOS using only several requests in a row. There are plenty of ways for that. You can see in the example that in one request we forced AEM to return 700 megabytes JSON and format it. It took about 6 minutes from AEM. Other tricks for the sake of completeness, I used them a couple years ago. They will rarely work today, but who knows. External job post servlet was vulnerable to untrusted Java deserialization bug in old AEM versions. It takes file parameter and passes it to object input stream read object call. Let's see how it works. We generate a DOS payload with tool called OS DOS and send generated payload to external job post servlet in file parameter. We see the error in the response that tells us that there is a problem with Java heap, failure to allocate required memory. Another thing is XML external entity vulnerability in WebDAV implementation I discovered in 2015. You can quickly spot if WebDAV is enabled by sending options request or making get request to the root CRX repository. And I created AEM hacker toolset to automate security testing of AEM web apps. Toolset includes several scripts. It will be published on GitHub shortly after the conference. The main tool, AEM Hacker, implements many checks and tries to bypass AEM dispatcher. And that's all, folks. Thanks for coming.
Thank you, Mikhail.